these positive terminal on this side, due to which there is a current will. What will happen if the light is incidenting on this? Okay. So after some time, this light will introduce only that much of a fixed number of electrons. Okay, a fixed number of electrons will be emitted for this particular light. At this time, at this time, it has reached its saturation current. Have you got that, beta? What is this? Have you got that, Peter? In this setup, the metal is there, cathode is being there, and the anode is there. Okay. Here the current is being allowed to flow. Okay. Now, what will happen if the light is incidenting on this metal surface? The electron will eject from here. Will it happen or not? Okay, due to photoelectric effect. But for this particular light, there is a fixed number of electrons that can be ejected. And these electrons get attracted by this positive terminal, due to which you will find the current over this region. You got this? For this particular wavelength of light, the current in the region get fixed when the most of the electron are being ejected. Have you got that, beta? Okay. And that current is called the saturation current. Okay. When the maximum number of electrons are being ejected by the incident light. Have you got that? Okay. Write the definition for the saturation current. Put the heading saturation current. The maximum number of electrons, ejected for a particular wave which cause.
Sir, we did this in class, right? B6 students.
But beta?
In B6 we did this, right?
In B6?
We did this, right? What you are telling now.
But some of them are there. Those who were not present. That's why.
B7 we did not do.
Huh?
Sir, in B7 we did not do. Right?
Yeah. That's why write it. What do you write, beta? Ejected from the metal surface by the incident light. By the incident light. At a certain time. At a certain time. The flow of these electrons. Flow of these electrons. Was the maximum current. Was the maximum current. Which is called saturation. Have you got that? Okay, now stopping potential. Stopping potential. If we increase or we decrease the potential of anode, if we decrease the potential of anode, then what will happen? The flow of electron towards this side start decreasing. Okay, the flow of electron towards this side, towards the anode side, start decreasing. If we decrease the potential of this side with respect to the cathode, that much the flow of electron stop. Flow of electron get stop. That potential of anode is called stopping potential. Got that, beta? The negative potential of anode with respect to cathode at which the flow of electron gets stopped, that is called stopping potential. Have you got that? Okay, write the definition then. It is the value of retarding potential. It is the value of retarding potential of anode at which the
Sir,
electron,
which chapter is this?
which chapter who is asking, beta? Dual nature.
Which chapter, sir?
Dual nature, beta.
Okay.
At which retarding potential of anode at which the photoelectric current becomes zero, called cutoff or stopping potential. The second name of this potential is also cutoff potential. Okay. Have you got that here? Cutoff. So most importantly, the graph between intensity and the potential, that is important. Stopping potential, intensity, and current. Okay. Can I rub this? Have you done, beta? So here we are taking V, here we are taking I. So what we have seen for retarding potential or negative potential, we have seen when we decrease the potential of anode with respect to cathode, this means the negative potential we have to apply, retarding potential. So at that negative potential, the current will become zero. That is our stopping potential. Okay. Cutoff potential. At this point, the current is zero. After that, if we increase the voltage, if we increase the voltage in this direction, the current is start
Sir,
increasing. Yes.
I have to go washroom. Can we delay 1 hour?
Huh?
I have to go washroom. Can we delay for 1 hour?
Delay for 1 hour, beta. Yes, beta. Okay.
Yes, sir.
What you are going to do there for 1 hour?
Sir, emergency.
Okay, beta, go then. But go to the medical washroom. It will be helpful for that kind of emergency for 1 hour. Okay. So here this kind of graph will come out after the potential. After this potential, whether he has gone or he is there.
You answer.
Gone.
Yes, sir.
So this kind of graph will come after certain voltage. After certain voltage, this graph attaining the saturation. This is saturation. And this is stopping potential at this point. Now, first effect of intensity. What will happen if we increase the intensity? Meaning of increasing the intensity means what? We are increasing the number of photons. If the number of more the number of photons will incident at this point, in that diagram, if you see, if you have drawn that diagram, if the more the number of incident photons will be there, more the electron will eject. Have you got that, beta? More the number of electron will eject, what will cause there? More current. Yes, it will cause more current. So this means the value of saturation current increases. If this is for I1, this is for I2, then if I1 is greater than I2 is greater than I1, intensity. Have you got that? Don't confuse with the current over there. I am representing with this smaller. Okay. So if it is a current for, it is an intensity for some radiation, it is another intensity for another radiation, then the saturation current will be maximum for the intensity which is higher. Have you got that here? But the stopping potential is same. Have you got that? Stopping potential is same. Why? Why the stopping? Because it is just increasing the number of electrons, not the energy related to the electrons. Because on increasing the intensity, the number of photon increases, not the energy related to the photon increases. If the energy related to the photon increases, then if that much of energy gained by the electrons, the kinetic energy increases of those electrons. If the kinetic energy get increases, so these electrons can easily get over their anode. Have you got that? So to stop those highly kinetic energy, energetic electrons, we have to increase the potential. Here in this case, we don't need to increase the stopping potential. Have you got that? On increasing the intensity, number of photon increases, which eject more photo electrons and increase the saturation current and also the value of saturation current. Have you got that, beta?
Yes, sir.
Okay. So here, the saturation current increases the intensity. Have you got that? Now, second, effect of frequency of photon, frequency of radiation. What will happen if we increase the frequency of radiation? What happened, beta? If we increase the frequency of radiation, more the frequency, more the energetic the photon, more the photon be energetic, they will give more energy to the electron. If they give more energy to the electron, then kinetic energy of the electron will be higher. If the kinetic energy of the electron is higher, then these highly kinetic energy or energetic electrons will be stopped by applying more potential to the anode. Have you got that, beta? Have you got that? But the intensity is same. But the intensity of photon is same. That has not been changed by increasing the frequency. If the intensity is same, okay, then the saturation current is same. If you have to add one more line over here, but the energy of photon is constant, is not changed, not change, due to which the stopping potential is constant. Okay, and it not change. Have you got that? All of you can see that at the downside effect of frequency.
Yes, sir.
If if higher the frequency of the radiation, more the energy of photon, more the energy of photon. Have you got that here? If there is a more energy of photon, means more the kinetic energy of electron, then more the kinetic energy of electron.
So the thing that you are writing, we can't see.
Okay.
We can't see what you are writing.
Okay, beta. I will turn it, then you can take the screenshot. Okay.
Okay.
More the energy of photon, more the energy of photon, then more the kinetic energy of electron, due to which stop these electron more stop these electron large stopping value of stopping potential. Value of stopping potential increases. Okay. Now you can see better. What you can see now?
Yes, sir.
Okay, have you taken the screenshot?
Yes, sir.
Okay, dear. Okay. If stopping potential is getting increased, then but the intensity is constant and intensity is constant due to which saturation current do not change. Okay, have you got that? Due to which saturation current do not change. All of you can see this now? Is it visible? Okay. Afif, you have asked a question yesterday regarding if we increase the potential, if we emit some of the electrons from there, eject some of the electrons, do the work function increase? Yes, beta, work function increase. But we are not using those material isolated in isolated system. Okay, they are always used in the circuit. Yes, they are used in the circuit, so they are getting the source of electrons. Okay, so they are being neutral. Okay. Have you got that here? No. What will be the graph regarding frequency? How it is changing with it? So the stopping potential changes, but the current, saturation current, is same. Have you got that here? The value of saturation current is same. On increasing the frequency of an incident radiation, the stopping potential, it is V1, V2, V3, increases, but the saturation current is constant. Okay, so if it has been asked, there are three radiations, one, 2, 3. These are the stopping potential for them. Then which one of the following is having a more frequency? Which radiation? 1, 2, 3. The stopping potential is there. Yeah, very good. Okay. Have you got that? The question may ask in the paper that graph may given to you or they will ask to draw the graph. Have you got that? Can I rub? Now, not derivation for value of stopping potential. What will be the value of its stopping potential? What's happening there? This what this stopping potential is doing. This stopping potential is trying to stop those kinetic, the energetic electrons, which has got the kinetic energy through photon. Got it here? What it is trying to do? It is trying to stop those electrons, isn't it? Okay. So this means this stopping potential is doing that much of work, as you see. The electrons are going from here, from this way. So these electrons reaching at this point, the potential is trying to be stopping that. So how much energy this proton is having in the form of kinetic energy, and this kinetic energy is getting zero there. Okay. So this means the work done by this negative potential at this point is being equals to the kinetic energy of this electron. Have you got that? Then kinetic energy of electron, maximum kinetic energy is equals to the work done by this part. That is how much? EV. That is the energy. Or it is a stopping potential. Have you got that, beta? Okay. What is the formula for this one? E max. It is E minus phi. The phi is work function. Have you got that, beta? Then V naught can be written as E minus phi. Have you got that? Then what we can write this? E minus phi upon E. What we can write this? We can write this H C by lambda E minus phi by E. We can write this where? We can write at this side not is equals to H C E lambda minus phi by E. We can write this in this form. Can we write this beta or not? Who is this? Hamza is in our class now. Can we write this? So this is our stopping potential.
Yes, sir.
Okay. So if we see the graph, uh, we see the graph between V naught and wavelength 1 by lambda and V. So this will come out to be somewhat like this. where this is one by lambda, or the incident frequency, threshold frequency, we can see. This is the work function by E, or phi by E, intercept. Phi by E. This is stopping potential. Got that? So this kind of graph we get for this. Have you noted down? Here it is, intercept. Here this one. Okay. Can I rub this? Take this screenshot. Just take it. Okay. So we have seen the stopping potential. So this was a case when the kinetic energy is being there in the form of that. If the electron is setting it. So have you got that beta? Stopping potential? Hmm? Okay, let me ask a question related to this. Okay, beta. Find the work function and the graph between stopping potential and frequency is given like this. This is frequency in hertz.